Hello, hello. Welcome to 13 Universal. Okay. So this is biological molecule. Okay, part five. So what are we have done? Biological molecule, different parts. We have done part one, part two, part three, part four, part five. So sorry, this is part five. We're starting with part five here. Okay. So and we're going to be discussing water, right? So water, you know that water is very vital to life. Okay, but before we go on, just a recap. Don't forget that biological molecules are actually building blocks of life. They are building blocks of life, building blocks of life, building blocks of life. That's biological molecule, and you can see that a cell is made up of biological molecule. All of these cells, you can see this cell here. All of these they make up this cell. You understand? So biological molecules help to build life. And today we're going to be looking at water. And very importantly, I want you to know that about 80% of cell is made up of water. So water is very essential. Okay. So come, let's dive in and then discuss water. Let's go to the next slide, guys. So the first thing I want us to talk about is that just like for every biological molecule, we have the structure, we have the property, and we have the role. Okay, so you see that the structure determines the properties, and the properties determines the role. Same thing with water. Okay, so we're going to discuss the first we're going to discuss is the structure of water. After that, we'll discuss the property of water, and then we'll discuss the role of water. The role of water. So that's how it's going to go today. So let's start with the structure of water. Structure of water. And if you bring it down, you can realize that water is basically start from that because it's a molecule. So it's made up of two hydrogen atoms, okay, and one oxygen atom, right? So let's look at it, how it goes. So water is made up of two hydrogen um, atoms, two hydrogen atoms, okay, and one oxygen atom. So if we look at it this way, if we look at it that way, we can have something like this. This is oxygen, right? And that's hydrogen, right? So you see how they appear actually, right? So if you look at it basically, guys, look at the structure of oxygen, you find that an oxygen has two shells. Okay, the first shell, right, is occupied by two electrons. The second shell is occupied. I'm just trying to explain it by six electron. Okay, so six electron. Wow, six electron. So oxygen actually wants needs two more electron to have complete octet structure. Okay, so we have of course two here, two pairs here. Then we have this. It shares one with hydrogen, because when it shares one with hydrogen, so it forms a shared pair with hydrogen. Okay, hydrogen brings its own shared pair, its own one electron, and it shares. So we have a shared pair here. You can see, guys. Yeah. Okay. So you see that hydrogen and oxygen. If you check there, you can see that what is linking them here is actually covalent bond because they're sharing a pair of electrons. They share the electron here, shared pair. Okay. Oxygen has two unshared pair and then has two shared pair here with hydrogen. So this bond, the bond that oxygen bonds forms with hydrogen is covalent. That's covalent bond. Okay. And but because oxygen is more electronegative, oxygen will pull this electron closer to itself, right? And then that leaves hydrogen becoming partially positively charged and oxygen partially negatively charged. Oxygen becomes partially, right? That's delta, negatively charged, and oxygen is partially positively charged. Okay, negatively charged. So you see that one thing about water is polar. So we can say that water is actually polar. Water is polar. So it's charged. You can see, and because of that, right, that's the structure of water. Now, don't forget that there's an unequal distribution of electron, okay, between oxygen. Oxygen pulls the electron towards itself. Sorry, let me clean this. Oxygen pulls the electron towards itself, and then that creates unequal distribution. Okay, and that unequal distribution is that oxygen pulls shear plate more to itself. So that's why oxygen becomes partially negatively charged and hydrogen becomes partially positively charged. Because of that, we we call that because let's go back. Yeah, we call that what we call dipole effect. Okay, so that's called dipole. Dipole is unequal distribution of charges, right? When we have unequal distribution of charge, that's called dipole. So we have what is called dipole. Yeah, yeah. So because of that, oxygen is negatively charged, weak. It has a weak negative charge, and hydrogen has a weak positive charge. So water is therefore polar, like we have said. Water is polar. And because water is polar, we are done with the structure now. So we'll go to the property. So you see, because water is polar, um, water can have some properties. Okay, I'm going to discuss the two common properties of water now. I'm going to and look at the rest later. So cohesive, cohesion. So water, right, exhibits cohesion and adhesion. Adhesion. Okay. So cohesion is spelled Cohision. So now cohesion is that water molecules actually what they do is that water molecule form hydrogen atoms with each other. Okay, so hydrogen bonds. Yeah. So if I have a water molecule here, right? This is a water molecule. This is oxygen, hydrogen, and this is um, negatively charged, positively charged. Okay, positively positively charged with positive charge, and I have another water molecule here. Okay, so now because water is polar, water is attracted to other water molecules. All right. So you can see that the negatively charged part of oxygen is attracted. They form hydrogen bond. So this bond here between um, two water molecule here is called hydrogen bond. Is that okay? So the bond is formed between one hydrogen. See, this bond is formed between the oxygen of this water molecule and the hydrogen of that water molecule. So this bond is called hydrogen bond. But the bond between oxygen of a water molecule and hydrogen of the same water molecule, like this one, we call it covalent bond. But if it is between another water molecule, it is called hydrogen bond. So water molecules form hydrogen bonds with each other. So water molecules stick to each other. Therefore, we call it cohesion. That is called cohesion. All right. It is called cohesion. Yeah, cohesion. All right. Now water molecules don't just have cohesion. It also has adhesion. But before I go to that, don't forget that cohesion, right? We say that it has cohesion. Cohesion is a property. Cohesion must have a role. One of the rules of cohesion is that cohesion helps in water transport. Okay, water transport in xylem. It has a lot of rules in transport. Anyway, water is acting as a transport mechanism. All right, cohesion plays a role. Now, in water transport, cohesion helps water column to be set up. Water column to be set up. Okay, in xylem, water column to be set up in xylem. right? So if this is xylem, let me try to, okay, let's just clean up. So let me clean up here so I can show you what I meant. So in xylem, basically, guys, mm, in xylem, if this is xylem, okay, let's take it down. Oh, this is xylem, this xylem wall, this under xylem wall, okay. So if this circle is water molecule, this underwater molecule, this underwater molecule, this underwater. So water molecules form hydrogen bonds with each other to set up water column, right? So that's one of the advantages of cohesion. Okay. All right. So now, but if you look at adhesion, for example, in adhesion, water molecules also form hydrogen bonds with other non-polar molecules because water is charged. Sorry, it forms hydrogen bonds with other, polar molecules like ions and other polar molecules. Take for example, if this is chloride ion, or let me say, if you have chloride ion here, right, and I have sodium ion here, okay, this it forms hydrogen bond with this oxygen. Can you see this negative part forms hydrogen bond, and this negative chloride ion forms hydrogen bond with that of hydrogen. All right, is that okay? Yeah. So that is it. So you can see that. So water also exhibits adhesion, adhesion, adhesion. Okay, it exhibits adhesion, adhesion. Okay, adhesion. Yeah, adhesion. So now, because of adhesion, water molecules can form hydrogen bond with the wall of xylem. You can see this hydrogen bond, and that helps to maintain water column. So why cohesion sets up water column? Adhesion, okay, maintains water column, right? Water column. Okay, very important. It maintains water column. Okay, don't forget that. So adhesion has a role because it helps to maintain water column during water transport. While cohesion helps to set up. So cohesion sets up water column. Okay. All right. So these are the um, properties and their roles. Okay. So let's look at other properties of water. For example, now I want to show other properties of water. Um, don't forget that water form cohesion adhesion with the hydrophilic part of lignin and the cellulose on the wall of xylem. Okay, so let's look at another important property of water, which is what we call heat specific heat capacity. So water has high specific, all right, heat capacity. Heat capacity. Now, heat capacity. What does that mean? That is the ability of sorry, not the ability, amount of heat required to increase the temperature of water by 1 degree Celsius. So if water is, for example, 21 degrees Celsius, you want to move it to 22 degrees Celsius, right? So you're increasing it by 1 degree Celsius. So the amount of heat required, right, to increase water from this 21 to 22 is called high specific heat capacity. Okay, especially if you're dealing with 1 gram, if it's 1 gram or 1 kilogram, call it specific. If you just amount of water, or just call it heat capacity. So specific talks about 1 gram. So water has high specific heat capacity. That means a lot of heat is required to increase the temperature of water by 1 degree Celsius. See? Hmm? So why? Because the hydrogen bond, remember that hydrogen bond, to increase the temperature of water, hydrogen bonds, all right, have to be broken. So which hydrogen bond? Hydrogen bond between water molecules. If this is water molecule and this is another water molecule, okay, and the water molecule partially, and this is partially positive, partially negative hydrogen bond is formed between them. So the amount of heat required to break this hydrogen bond, all right, is high. So that's why we require, okay, high amount of heat. That is why water has high specific heat capacity. And because of that, guys, now it is not just to increase water, the temperature of water, even to decrease the temperature of water. Now, because of that, it's very important to know that water, okay, is therefore water. This is very important. Water is sluggish or reluctant, okay, to change in temperature. Change in temperature. So water is reluctant to change in temperature, whether increase or decrease. Okay. So water is reluctant. So water is reluctant or sluggish to any change in temperature. Therefore, that means that water helps to maintain, yes, to maintain it gives relatively all right constant temperature. It helps maintain temperature of either an organism or the water body, right? So water acts as a buffer, but don't use the word buffer. I'm just buffer means something that's resistant to change. So it acts as buffer to change in temperature, right? Change in temperature. That means it maintains temperature. Because of that, because water, now this is a property, guys. Don't forget that structure determines property and property determines role. The role of water out of this property, the role here is that water basically, all right, maintains constant temperature of the body or um or an environment. Okay, so the role here is that water plays a role in homeostasis because water has high state homeostasis because it has high heat capacity, so it maintains constant temperature. Okay, so that's very important. All right. So now remember we have mentioned the role, and then what determines the role is the property, and what determines the property is actually um, the okay the structure. Okay. So another important property of water, we're going to look at this again. All right, is that water, very importantly, remember because water form hydrogen bond with each other, it plays an important role. Because of this hydrogen bond water forms, you see, this is water molecule, guys. Hmm? This is a water molecule. Positive, partially negative, partially positive. This is another water molecule. Do you get partially positively charged, partially positively charged, partially negatively charged. So because they form hydrogen bond, right? That's hydrogen bond. This is hydrogen. This is H bond. H bond, right? All right. So because of that, to break this bond, a lot of energy is required to break hydrogen bond. Now, because of that, water has another higher under property called latent heat. Water has high, okay, heat of vaporization. Heat of vaporization. Vaporization. Okay. So heat of vaporization, called it high latent heat. We call it latent heat of vaporization. Latent heat. Okay. Latent heat of vaporization. Now that is the amount of water, so the amount of heat required to convert water from liquid. Anytime you want to convert water from liquid to vapor, a lot of energy is invested. Why? The energy is required to break hydrogen bonds, guys. Okay, so a lot of energy is needed to break hydrogen bonds. This hydrogen bond you see here. So to convert, that means anytime water is converted from liquid to vapor, okay, a lot of heat is removed from the body of living things. For example, when organisms sweat evaporates from the body of mammals, all right, transpiration occurs and vapor is lost from plants, a lot of heat is lost. Okay, so because of that, anytime evaporation occurs, all right, evaporation leads to coolness. This leads to coolness. Okay, so this is a property. That property is that water requires high amount of heat to be converted from liquid to vapor. Now, what advantage does it give to living things? The advantage is that it helps to remove. Now, this removes, all right, excessive heat, excessive excessive heat from the body of organisms. Okay, that it helps remove excessive heat, and that prevents okay enzyme denaturation. It prevents enzyme denaturation. Very important. And apart from that, that leads to coolness. Okay, yeah. So whenever there's high amount of heat in the body of a living thing, it is removed, all right, by just simply converting water from liquid state to vapor. All right. So, and that helps to remove excessive heat, okay, leading to coolness and preventing enzyme denaturation. Okay, don't forget that, guys. Very important. All right, so let's look at other important properties. Remember that anytime you mention property, you must connect it to role. All right, there's a role it plays. There must be a role it plays. There must be a role it plays. So that's very important. So another rule we have mentioned um, a lot of properties. So let's go to the next one. The next one is what we call surface tension, right? Surface tension. Yeah. Surface tension is simply um, a force that acts on the surface of water. Is a force. So that force acts, all right, acting, the force that acting, all right, or force acting on the surface of liquid or water, right? So that makes the surface of water to become elastic. So surface of water becomes elastic, elastic, produces elastic surface. Okay, very important. So now don't forget that they ask you why does water have surface tension? You see, why has it? Because of cohesion. The cohesion between water, all right, molecules at the surface. It is water molecule, and this is surface of liquid. So water molecules form cohesion with those beneath it. Cohesion between water molecules at the surface and water at the beneath. Okay, of course they form between those at the surface, but they form with those at the beneath. So now, what is the role of surface tension? The role is that it allows, for example, insect like pond skaters, pond skaters, all right, pond skaters to walk on water, walk, all right. Pond skaters can walk on water, so insects can walk on water, okay, yeah. So some lizard can walk on water now because of surface tension. That allows aquatic organisms to escape from predation, or like lizard escaping or looking for food, and pond skaters also, feeding, all right, other insects. Okay, now that's about that. We're going to still recap this, but let's look at another property of water. Very important, another property of water. Another property of water is that water, there's what is called abnormal behavior, all right? Abnormal behavior of water, behavior of water. Now, that states that between 4 degrees Celsius to 0 degrees Celsius, okay, that the density of ice, all right, density of ice is is less, right, less than density of water, okay, liquid water. Remember that ice is solid. Solid should have higher density, right? But here ice has less density between that temperature, okay, all right. So that's an abnormal behavior of water, you get. So that is why ice floats. Ice floats on water. Okay, ice floats on water. Okay, because of this abnormal behavior, ice floats on water, and of course, ice is also a poor conductor. Ice is a poor conductor of heat. So ice does not allow water beneath it to lose heat. So if, for example, this is an aquatic body, just give an example, right? And then temperature in some part of the world during winters, right? And of course, what happens is that once ice is formed, the ice floats on the surface. See, ice comes to the surface. And when ice comes to the surface, it prevents heat loss, water heat loss, right? Because it's a poor conductor of heat. Therefore, it keeps water beneath the ice warm, all right? And that prevents complete freezing, complete freezing, freezing of the aquatic life, okay? Of the aquatic body and preserve aquatic life. So that's abnormal behavior water, abnormal behavior water. Is that okay? Yeah. Quickly, let's look at another property of water. Okay. Water, very importantly, water. So I'm just discussing this here. I won't finish. We recap on that. Water also is a universal solvent. You know, water is a universal solvent. So water is a universal solvent. Okay. All right. So water is a universal solvent. Now this means that water dissolves polar molecule, dissolves most polar molecule, dissolves, all right, molecules, dissolves substances or molecules, right? Yeah. And then when it dissolves them, it helps to transport them. Okay. So that's why water is involved in transport. So once it dissolves molecules, it transports them. For example, in blood plasma, you see blood plasma, right? Blood plasma transports molecules like proteins, glucose, amino acids, a lot, right? Even in um, sucrose, right? Or in the flame, flame transports sucrose, right? And other similarities. So water helps to do all those transport. So water sets up hydrostatic pressure gradient. We're going to deal with that when we get to that topic. So also water, being a universal solvent, creates aqueous, okay? Aqueous medium. See, water creates aqueous medium for metabolic reaction. Metabolic reactions. Okay, metabolic reactions. All metabolic reactions. Okay, that's why all metabolic reactions occur in water. If there's no water, all right, most of these metabolic reactions cannot occur. So water plays a major importance. So this is a property. All right, these are the rules. Okay, so dissolves most molecules. Therefore, what role it helps in transport, helps in creating aquatic aqueous medium for metabolic reactions, guys. This is very important. All right. Now there are other things that water do. For example, water can act as a metabolite during photosynthesis. Okay, so water during photosynthesis can be split to act as a source of proton, right, and electron. Okay, and of course is the source of oxygen during photosynthesis, right? During photosynthesis. Okay, so yeah, that this is what photolysis of water. This is what photolysis. It occurs during the light dependent stage. So water can be split, right? Okay. So having said that, let's go on, right, and look at now water also helps in hydrolytic reactions. These are other rules. Hydrolytic reactions, just to mention. Okay, to break down molecules, water helps to provide turgidity and support. Turgidity and support. Okay, all right, let's go. Okay, look at it. So see that's one I've done the structure of water. You see that you have mentioned that it has oxygen that is negatively partial negative charge and this partial, okay, and all of that. Hydrogen is partial positively charged because of unequal distribution of electrons, or we call dipole. Okay, okay, dipole. Yeah. So let's look at that. So look at knowledge check one. So which diagram correctly shows hydrogen bond between two water molecules? So I want you to pause the video and solve this. Okay. Is it A? Remember that why is A? Is A the answer? Close, but not really, because the bond between oxygen and water, so between oxygen, right? The charge on oxygen, right, is partially negative. The same thing with hydrogen, partially positive. So you must put that delta, weak charge. So A doesn't have that, doesn't have this delta, positive for oxygen or delta, negative for sorry, delta negative for oxygen and positive for hydrogen. So it is not the answer. Okay. Now he has it, right? Yeah. So yeah, B seems to be the answer. What is wrong with C? Because hydrogen is not negative. Hydrogen is positive. Oxygen is, yes, weak negative. So that's why this is wrong. What's wrong with, okay, D? There's no, of course, this is showing positive for oxygen. This is showing negative. This is the other way around, and it should have um the weak charge. Okay, so which is represented as delta, either plus for hydrogen or delta we charge negative hydro for oxygen. So that's why the answer is B. Okay, let's go to it. So you see all we have said, about water. Quickly, the hydrogen bonded water molecules contain two hydrogen atoms and one oxygen atom held together by hydrogen bond. Solvent, you see, water is a solvent. Water is an effective solvent. Now, this is a property. Then it's effective solvent because of its polarity, because it's charged and so can form electrostatic interactions with other polar molecules. Yeah, the attraction and ions. Other polar water molecules and ions and other water molecules. That's adhesion. Okay? Adhesion is with other polar molecules. Is that okay? Yeah. Now, it's a toss, it's a transport medium. So this is a role because it's a solvent. This is a property. Solvent is property, guys. Okay. Now, transport medium, right, is a role. Water is a transport medium. Reagent for metabolic reaction is also a role. Okay. All right. So now let's go to, so water interacting with ions. You see, water can interact with ions, right? You see, water interact with ions. See the positive ion interacting with oxygen. Oxygen is negative. This is positive. Okay. Say the negative ion interacting with hydrogen part, which is the small part, right? Okay. Um, yeah. So you can see that. So let's look at knowledge check, guys. Knowledge check. Okay. So what is the maximum number of hydrogen atoms that can form between two single water molecules? I want you to try this. Okay. Two single water molecules. Pause the video and try it. All right. So if I have a water molecule, this is a water molecule. Okay. This is hydrogen. Hydrogen. Okay. Hydrogen is right weakly positively charged. Oxygen is negatively charged. Positive charge. Okay. There's another water molecule with hydrogen here. Okay, connected to oxygen here. Okay, hydrogen here. Partially positively charged. Partially or weakly negative charge. Partially. So the only way, because they're asking us maximum number of hydrogen bonds that can form between two single water molecules. So this is a single water molecule. This one here is also a single water molecule, right? Remember, this is negatively charged. That is positively charged. Okay, so they can form hydrogen bond here. One, this is one. Now, okay, I think it's only one hydrogen bond that they can form. They can form more than one. So the answer is A. They can form more than one. All right. It's not two, it's not three, it's not four. Just it's one. One is maximum. Okay, look at the next question here. So what is the maximum number of hydrogen bonds that can form? Is it maximum? They're asking us for maximum number of hydrogen bonds that can form between a single water molecule. Now this is a single. The other one was two. The other one we saw was two single. See, two single water molecules. All right. But this one is saying between a single water molecule and other water molecules. Wow. Single and other water molecules. Pause the video and try it. Okay. So if we have a single water molecule, guys, let me try to write it again. Remember that um, this is water, right? This is oxygen or water molecule. This is hydrogen, right? This is another hydrogen. Okay. So this is partially negatively charged, partially positively charged. Okay. Partially, right? Positively charged. Okay. Now this hydrogen here can form hydrogen bond with another water molecule. Okay, this is water molecule here, partially positively. That's hydrogen of that water molecule, partially positive, and this is that of oxygen. That's negative, so they can form hydrogen bond. Right? Okay, this one can as well form hydrogen. There's oxygen here, the water molecule. That's hydrogen, water molecule, partially negative charge, partially positive charge, partially positive charge. Okay, this one is hydrogen. This water has two. Remember that oxygen has two unpaired electrons, unshared electrons. Okay, so each of them will form hydrogen bond with underwater molecule. Okay, this is underwater molecule here. Okay, this is partially negative, partial, sorry, positive is negative, right? Negative here, right? So this goes like this, and hydrogen um, bond. Okay, remember there are two. That's for one. So let's go to the other two. So this will form hydrogen bond with hydrogen of the water molecule is underwater molecule, partially positively, partially negatively charged, partially positive charge. So this forms hydrogen bond. So the two unpaired will form two hydrogen bond. So if you count the hydrogen bond that this single water molecule forms, okay, it forms hydrogen bond with four water molecules, forms with one, two, three, and four. So how many hydrogen bonds? One hydrogen bond here, two hydrogen bond, three hydrogen bond, and four hydrogen. So four. So it's not one, it's not two, it's not three. The maximum is four. Minimum is, of course, maybe one. Okay, but maximum, yeah. Because we're looking at single water molecules and other water molecules. All right. So see what we said before. That water, this is a property of water, high surface tension and cohesion. So high surface tension is due to cohesion. Cohesion refers to the attraction of one water molecule to the other. Water molecules have strong cohesive forces due to hydrogen bond. Yes. So they have strong cohesive forces, thus having high surface tension. So it's high surface tension that gives them, it's cohesion that gives water, right? High surface tension. So like I told you, the water molecules, okay, at the surface of a liquid, all right, form strong cohesion with those beneath. And okay, and that gives us high tension, surface tension, high surface tension. Like I told you, surface tension is just a force acting on the surface, on the surface of water. All right, and like I told you, every property, this is a property, has water has high surface tension, therefore insects walk on water. Okay, other organisms can walk on it. Okay, they walk on water. All right. So now see another check here. So the movement of water through the vascular tissues in plant relies on which property of water? Okay. So if water is moving through the vascular tissue, we mentioned that. I want you to pause this video and try it. Okay. So water is moving through maybe xylem, okay, and we said that if these were the walls of right? Xylem, and these circles are water molecules. So water molecules to move up there, they have to form hydrogen bond between themselves. That's cohesion, right? And that setup, cohesion helps to set up water column, and then adhesion helps to maintain water column. Is that okay? Mm. All right. So let's look for adhesion and cohesion. A says changes in density with temperature. No. B says good solvent for ions and polar molecules. Well, no, this is for transport. All right, because they say water movement through vascular tissues. They say high specific heat capacity. This helps to maintain temperature. Okay, right. But this is strong cohesive forces between water molecules. Yeah. Okay. Even though they didn't show us adhesion, but cohesive forces, strong cohesive forces helps to set up. He helps to set up water column. Okay. All right. So look at it. The next one. This is another property of water. We have said it before. Okay, heat capacity. Okay, high water has high specific heat capacity. The amount of heat energy required, that's definition, to raise the temperature of 1 kilogram or 1 gram of water by 1 degree Celsius. So to increase water by 1 degree Celsius requires a lot of heat. Okay, there's high heat capacity. So water has high specific heat capacity due to its hydrogen bond. Yeah, as we said it, a lot of heat is required to break hydrogen bond, right? Temperature within organisms remain constant. That's the rule. Hmm? That is the rule. So this is role of water. Water maintains temperature within organisms constant. Why? Because of the property. Because this is property. Because water has high specific heat capacity. That's a rule. Don't forget it. Okay. Compared to external temperature and water bodies, also have a slow change in temperature, providing stable aquatic. So it's not just within organisms. Even when you find water in aquatic body, it helps to maintain steady, constant temperature. Okay, let's check it out. Which statement correctly explains why blood plasma can be maintained at a stable temperature? Why does it? What property maintains it at stable temperature? Stable temperature. Stable temperature. A says it has low specific capacity. No. B says it has high specific capacity. Yes. Remember that his heat capacity, high heat capacity of water is related associated with stable temperature. High heat specific capacity of water helps water to maintain specific temperature, stable temperature. That is constant temperature, right? Now, since it has low latent, no, latent heat does not have anything to do with that. I don't know. Latent heat helps remove excessive heat, okay? Not to maintain it. All right, look at this. Which property of water minimizes temperature changes in cells and organisms? Pause the video and try it. Minimizes temperature changes. Minimizes temperature changes. That is, minimizes temperature change. That maintains, this is same as maintains relatively constant, right? Temperature. Okay? Relatively. Is it cohesion? No cohesion. Now, cohesion, of course, is the reason for this, for high specific capacity, right? But there's a property that does that. Maximum density, no. Heat of operation, no. Okay, it is specific heat capacity. So specific capacity minimizes temperature change. All right. So the answer is D. Okay, it's not B. It's not A. It's not C. Delta. Okay, look at another property. Water has high latent heat of vaporization. Now, what is it? Measure of heat energy needed to vaporize a liquid. Water has a high latent heat evaporation due to its high specific heat capacity, as hydrogen bonds need to be broken. So hydrogen bond needs to be broken. All right. So to convert water, all right, from liquid to vapor, you have to break hydrogen bond between water molecules. As it requires high heat of vaporization. Right? See, broken hydrogen bond needs to be broken before water can be vaporized. And the result of what? Cooling the surrounding environment. Sweating is a good cooling mechanism. Yeah, because by the time water is moved from liquid to vapor, a lot of heat has been taken from the body. All right, it results of cooling. However, a large amount of energy can be lost, yes, for little amount of water. Thus, dehydration is prevented. Example in transpiration. Okay, so look at this. Now look at what we just said, density and freezing property. Ice is less dense than water and floats on it, we mentioned before, right? As a normal behavior of water. Insulating water, it has poor conductor, poor is a poor conductor of heat, so it insulates water beneath it and preventing it from freezing, preserving aquatic life underneath it. Okay, so anytime ice floats on top of water, it prevents loss of heat. Okay, it prevents it. Heat cannot be lost. So every water beneath aquatic life is preserved, right? So cause current, which helps in maintain circulation of nutrients. So that means that here becomes warm and then nutrient can be circulated, all right? Apart from preserving aquatic life, you have to circulate nutrients. What does that mean? So because here is warm, so nutrients can come to the surface here so that aquatic life there can survive, all right? So knowledge check. Certain insects are able to stand on the surface of pond. Why? Which property of water allows them to do this? We have done before. Adhesion with other molecules. Pause the video and try it. No. Low viscosity. Right? Is it low viscosity? No. B says cohesion between water molecules. Yes. Now that ability is what we call surface tension. That property is called surface tension. Water has high surface tension. And why? Because of cohesion. Cohesion. Okay. So cohesion between water molecules at the top and those at below. Okay. Yeah. So cohesion is the answer. This is not the answer. Okay. All right. Now look at next one. It's as a frozen lake warms after a cold winter, mineral nutrients are brought to the surface. You should solve this question quickly. Which properties of water contribute to this process? Its greatest density is at 4 degrees Celsius. Yes. It has high specific heat capacity. No, that has to maintain. It is a solvent. Yes. For it to mineral nutrients dissolving it. Yes. Its molecule form hydrogen bonds. All right. The water molecules form hydrogen bond, which is connected to cohesion. All right. But it's not what makes it dissolve mineral nutrients. What makes it dissolve mineral nutrients is adhesion. Okay. What makes what helps to all right keep the water warm at cold winter is because of this abnormal behavior, which is why its greater density is at 4 degrees Celsius. This is why ice floats on water. Okay, so it is 1 and 3A. Okay, so look at this. A student wrote 4 statements about water. Let's check the one that's correct. Pause the video and try to solve it. Water has high specific heat capacity, which maintains temperature of water within cells. Is this correct? Yes. Number two, mammals rely on water having a relatively low latent heat of origin. No, water doesn't have low, it has high. Okay, high. So this is wrong. When a negatively charged ion is added to water, the positively charged on the weak, yeah, that's sigma, the weak charge, the weak positive charge on hydrogen ion atoms attracted to the ion. Yes, good. That because negative goes to positive. When surrounded by water, non-polar molecules tend to be pushed apart from one another. No. So when non-polar molecules are surrounded by water, they are running away from water. They are withdrawing from water, so they stick to each other, don't push each other away. And that attraction is called hydrophobic interaction. Hydrophobic interaction, right, is the attraction, okay, between non-polar molecules because they are withdrawing from water. So we have 1 and 3. That's the answer. So which one has 1 and 3 correct? 1 and 3 correct. Okay. 1 and 3 correct. 1 and 3. One. Okay. You take it. Mm-hmm. They say when surrounded by water, non-polar molecules tend to be pushed apart from one another. Well, okay. Let's look at, yeah, 1 and 3 correct. Yeah, that's it. They don't push apart. So B is the answer. Okay. Thank you for watching. Want to stay, like, subscribe, and turn on the notification bell. Okay, if you have comment, post it. Okay, so Thank you. See you in the next topic, which is enzyme. Bye for now.